Well, alrighty. It's time to start another streak because I couldn't get the hard one. Well, to be honest, I didn't really think past the time I spent yesterday, 30 or whatever minutes on it. Whatever. Right, today's deal: detect cycles in a 2D grid medium. Given a 2D array of characters grid of size m by n, you need to find if there exists any cycle consisting of the same value in the grid. Any cycles consisting of the same value. A cycle is a path of length 4 or more in the grid that starts and ends at the same cell. From a given cell, you can move to one of the cells adjacent to it in one of the 4 cardinal directions: up, left, right, down, if it has the same value of the current cell. Okay. You can also move to the cell that you visited in your last move. For example, a cycle 1, 1, 1, 2, 1, 1 is invalid. Oh, you cannot move cell in your last move, yeah. Return true if any of the cycle the same values exist in this grid, otherwise return false. So there's a cycle of A and there's a cycle of B. Okay, yeah. Here there's a cycle of C, right? And here there's no cycles because you can't move diagonally. Okay, pretty straightforward. This is yeah, it's pretty straightforward, I feel like. Let me think how I want to do this. This is almost certainly some sort of stack that traverses two adjacent paths. So I think I want to do something like I want to have a scene, and normally I was taught to just use a simple set here, a set that returns maybe true. Yeah, normally I just use a set to contain all the cells that I've been to, but I think I can use the more efficient 2D array of true false. So actually let's go ahead and define the rows and columns for the length and for the dimensions of the grid. So rows is the length of the grid, columns is the length of the first row, and then scene is just going to be false times the number of columns for every row. And just go ahead and verify that this is correct. Okay, so the first, wait, is this always a square? No. Is there any of these that's not just fudge me? Okay. Let's go and just delete. Or let's go in this test case and delete a row to make sure that the scene is not dealing with the square matrix. Alright, so it should be just like false, 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 false in the second row. Did I print the scene? Did I do this wrong? I think I might have done this wrong. It's supposed to be false times, it's supposed to be like this. Doesn't seem right. Maybe. Okay, yeah, whoops. My poor syntax. Okay, yeah, false, 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 false. 2D array, that's 2 rows, 3 columns. Okay. And then for this, I think I'm generally going to iterate over every starting position and then try to form a cycle from that position. Actually, I still, when forming a cycle from position, I still might need to have its own current set. Fuck. Okay. Okay, so for every row, starting row, in range rows, and then for every starting column, in range columns, I'm going to go ahead and just have a current set of maybe it should have the current position. This is connected positions from start. And I think it needs to have a stack. And then it's going to iterate to the neighbors of the stack. So I'll need to have some sort of movement. So deltas is going to go over like the movement in the position. So it's like 0, 0, 1, 1, 0, 0, -1, -1, 0. These are all the ways that I can change the row and column. So this should be while there exists a stack. Let's say current R and current I can just do row and column, I guess. Stack.pop. And then for every drdc in the deltas list, I guess I should make this a list. Then the nrnc is the new row, new column is row plus dr, col plus dc, and then if I would normally need to have some sort of if statement to check the grid at this position, except I also want to make sure it doesn't go out of bounds. So I'm gonna do a small hack here. Actually, I need to do a hack over here. Hack extend grid dimensions by 1 to prevent out of bounds indexing. So for every, I think row, actually for every row in range, actually I guess it'd be for every row array in the grid, row array appends, I don't know, just an underscore, and then grid.append underscore looks like a face times I want to say times the number of calls. Okay. Maybe it should be calls plus 1. That's fine, probably. So here I can just say if grid at this new row, new column, and even if it goes out of bounds normally, it'll just go to one of the underscores here. I guess I should probably just have a storage of the current value. current value is equal to grid at this row column. So if the grid at the new row, new columns equals the current value, or I guess maybe if it doesn't equal, then skip it. Or okay, actually, if it doesn't equal, I need to also check if it's already seen. I guess maybe, what am I doing here? I can't go backwards, huh? If I go from here to here, can't just go backwards. So let's go forwards here, here. That's actually kind of rough. How do I make it not go backwards? I think I learned this at some point. How to detect a cycle. Because if this is my starting position, I'm going to push this onto a stack, I'm going to push this onto a stack. Also need to push the direction it was coming from, so that it didn't go back in that direction. Push this onto the stack. This thing from here, it can't go backwards. So it would detect that this thing is, part of the current set. So go forward, forward. Forward. I wonder if it, I wonder if I could do something where I push one away, two away. So something like the B's here. Starting with this B, I push this one and push this one onto the stack. And then when this one processes, then it would push this one onto the stack. And then when this one processes, then it would push this one a stack. Maybe if it pushes the same thing twice in the stack, then I know that it's coming from two different directions. Like, say B, 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 B. So pushes this into a stack, pushes this on a stack. Maybe it should be a Q. Then this thing pushes this and this. Push this, push this, push this, push this, push this, push this. Yeah, I guess. If something is pushed onto a stack by two different things without being processed, it might be a cycle. Go ahead and make this a queue then. Double in a queue. Should have been set. Well, how would that work? This thing pushes this and this. And then and then this thing pushes this and this. Maybe I should be including the position or the distance from the origin. And then I can do a no. Push this thing. This should be pop left. So it pushes, takes this. It'll check this, but that's Ori. Okay. Let's say it's equal to current value and RNC not in the current set already. And pushes it to the current set. And it pushes that to the current set. Maybe I need to keep track of the number of times it's traversed a particular position. Maybe this should be not a hash, not a set, but dictionary. Current dictionary. And number of times visited. it's going to be it's so map it to can also map to the distance. Number and distance. Key equals connect position values distance. So if I ever find going to a particular position again with the same distance, then that means there's a second path to it. I think can't go back to the origin. There should be some, if there's a cycle, there should be some sort of place where two ways go to the same position with the same distance. Okay. Okay, NRN. So maybe it should be this thing, and like the current distance is part of it, part of the tuple. So for every delta move, if let's say if NRNC is in the current dictionary, is in the current dictionary and current dictionary of NRNC is equal to distance plus 1, then return true. Okay. I think this needs to be a separate statement. If otherwise, this means that otherwise it might mean I'm just backtracking. So continue. I'm going backwards. Okay, yeah. Okay, so then otherwise if the new placement has this current value, then this should be something that's added to the current dictionary at this point. Current dictionary of NRNC is equal to distance plus 1. One more distance from this one. And then deck.append the tuple that is NRNC distance plus 1. That might work. So then it does like this B, well, let's say it's just simple square cycle. Does this A should push this A onto the stack, onto the deck. Does this A pushes this A? Okay. I think that might work. I still need to set scene. So if scene for RC is true, continue scene RC is equal to true. And I also need to do scene for this location. I could do it when doing this part, probably. Fine. All right, I'm sure I'm doing something bad, but let's see how it goes. Quite ominous. Maybe it's too slow. Yeah, it looks like it's too slow. Interesting. So let me just go ahead and print out how badly this is. Oh, whoops, I forgot to use this as a test case. How big is this? Like 500 by 500, okay. Not very big. I would have thought it would have detected the cycle pretty quickly for that. Like, oh, it's actually, there's no cycles here, huh? Is it like a maze? $500, so there's a B, and then, interesting, there's like, it's a long row of 500s with a B at the front and at the last. The second row is all B's. The third row is a single B, so maybe there's a column of B's. The first column's B, and then there's alternation of B's and A's. I would have thought this wouldn't be that slow for it. Could be wrong. Okay, what am I doing wrong here? Or why is this too slow? So does the first B says it's seen, values B, current dictionary. I wonder if there should be 0. I think there should be 0 actually. I wonder if that makes a difference. No, it's still too slow. Okay, so if it's seen as true, then skip it. Seen as true here. Current value, current dictionary, deck, pop left, for every delta, NRC, if NR, if it's already in the current dictionary, then if it's a cycle, otherwise skip it. If grid NRNC equals the current value, current dictionary, current dictionary of that spot is distance plus 1, append, scene of that thing is true now. Okay, I think I need to just, I feel like this shouldn't be going backwards, but maybe I'm wrong. Should just be doing 500 times 500 times, really. Deck. Why is this going too many times? Seen at this position is true. Oh my god, I'm such an idiot. Such an idiot. I'm so bad. Such a stupid mistake. Like, it's just bad. Shouldn't be making that because that's really hard to tell from someone that's not, or like if I had to take a break and had to redo this code, it'd be really hard for me to tell that that was the mistake. Okay. So it's okay-ish in terms of speed. Is there some sort of redundancy? Like, could I just use scene as the single source of stuff? Could I just use current dictionary and not scene at all? Could I use scene and just interesting. I could just use scene instead of the current dictionary. Scene maps to not a boolean, but just a value for the number of distance that's been. Okay, I think that's fine. So let's say scene is -1. If scene not equal to -1, skip it. At this point, scene should be equals 0. Scene at this position is 0. Then I can get rid of the current dictionary. Yeah, I think that's fine. So current dictionary, deck, for every delta, I think here I can say if the grid at the new position not equal to the current value, continue. Okay, so some of the logic needs to change here. So if it's not equal to the current value, continue. If seen at this new position is equal to -1, which means that it hasn't been seen before, then seen at this position, new position, is equal to distance plus 1, and then deck appends this position to be explored. That's the same thing as, this is the same thing as saying scene to true. And then else if scene at the new position is equal to distance plus 1, that means it's backtracked, or that means that it's not backtracked, but going to the same position twice. So that returned true. I think that's correct. We'll see. Missing closing paren. Okay. I think this seems right. Okay. Okay. I think that's as close as I'm going to get to, or that's as optimized as I'm going to try to get. Okay, sure. Summary. So here, problem is similar to those that attempt to find cycles in graphs. I'm not quite sure, or I don't recall the normal ways to handle this, but the approach above, well, works. So in general, want some way of tracking positions and maybe how often they've been visited. In the above, used a mapping for position to distance from start position of current kind of island / group of connected positions with same value, where the island is like an island of A or island of B or island of C, island of D, island E, whatever. So whatever current values you start with. So for each starting position in grid, create if position hasn't been seen. So seen is the matrix that goes from position to some number distance, where the number distance is by default -1. So if it hasn't been seen, so -1 for value in matrix at that position. Use a deck of tuples, row, column, distance. Deck being a double-ended queue. Starting with that position. Pop while there are positions to be processed in deck. Basically there is some tuple in the deck take the front, pop left, iterate over every neighbor position using nr equals the row plus dr, nc equals row column plus dc, delta row delta column for drdc, and generally you just have a deltas list, which with your drdc for every position movement, and then you iterate over that deltas list and find the new position using the current drdc. I also use my normal hack of adding elements to the rows and columns to make sure that there is no out of bounds indexing. So adding an extra row and extra column basically to the sides of the original matrix. Over every neighbor position, if it has the same value, if new position has same value as current value, the current starting value. So if like starting with a C, if this position also has a C, which matches a C, or this position has a C that matches a C, then check the distance of that position in the scene matrix. If it's distance plus 1, then, or if it's a lower distance, skip, because that's like backtracking. If its distance is -1, reassign, so it hasn't been seen. If it's already distance plus 1, then cycle detected. Return true. So if you start here, you move here, this thing is originally -1, so now you assign it 1, this being 0, and then when you're here and you're processing the neighbors to this, so this thing, you find that this is distance 0 already, which is more than 1 plus 1, more than 2, or less than 2, so therefore you're just backtracking, so ignore that. Here you're assigning this thing from -1 to 2, and then when you process this thing, you assign like this to 3. But since this is a deck, then you're processing this, and this, this, and this, this, and this. You're processing kind of increasing distance from the starting. So eventually you'll get to something that has, you'll get to a position that is kind of, if there's a cycle coming from 2 sides, so like this thing will assign this distance to be 1, 2, 3, 4, 5, but then this thing will also assign this, when you process this position, it will also assign this thing distance 5, and that detects a cycle. That's just a really long-winded explanation of this logic right there. Skip any non-current value, assign it if it hasn't been seen before. There's a missing else here, but like else, if it's like a lower distance than distance plus 1, then that means you're backtracking, and it doesn't do anything in that case. Okay. Time complexity, this can be O of n, where n is the number of cells in the matrix, since all cells will be visited at most once, with constant work. at each cell. Yeah, so you're really preventing any backtracking or duplication of visits to a particular cell. Basic complexity can be O of n. N is the number of cells in the matrix. The process deck might have tuples for every position, basically. Let me think about that.